Come back again. This time around I've come again with another presentation. I'll be looking at the Northwest Regional Mock Proposed Solutions, Pure Mathematics with Mechanics Paper 2. I doing the presentation, I'm Tata Ernest, and we are going to begin right away. There were altogether 10 questions in this examination, but because the questions are so long, I will just present the proposed solutions for the first 5 questions. So if you want to have the proposed solutions for the other questions, then you have to stay tuned to the channel so that when I upload them, you'll be amongst the first people to receive the video. Now let's begin right away with question 1. Question 1 is on polynomials and functions. Given that x squared plus x minus 2 is a factor of p of x, where p of x is x cubed plus 4x squared plus ax plus b. Find the values of a and b. Hence, factorize p of x completely. Now, we have been given the divisor, and here is the divisor, and the divisor has been given in the quadratic form. So what we need to do is that we need to express this quadratic divisor into the product of its factors. So factorizing this quadratic term, we have x plus 2 into x minus 1. Now, if this divisor is a factor of p of x, it implies that the factors of that divisor is also a factor of p of x. That means x plus 2 and x minus 1 are both factors of p of x. Now, the next thing to do is that we need to find the zeros of this expression by equating it to 0 and finding the value of x. If x plus 2 is equal to 0, it will imply x is equal to negative 2. And if x minus 1 is equal to 0, it will also implies x equals to 1. Now, if x equals to 2 and x equals to 1 are the 0 of the polynomial p of x, then if I substitute negative 2 into p of x, I will have 0. And if I also substitute 1 into p of x, I will have 0. So p of negative 2 will give me 0 and p of 1 will also give me 0. Now, let's substitute negative 2. What is p of negative 2 equated to 0? I'll plug in negative 2 everywhere I see x. I'll have negative 2 cubed. I add it to 4 into negative 2 squared. I add it to a into negative 2. Then plus b is equal to 0. Now, multiplying the exponent and simplifying, I'll have negative 8 plus 16 minus 2a plus b is equal to 0. Now, negative 8 plus 16 is the same as 16 minus 8. So I have negative 2a, then negative 8, which is the result of positive 8, which is the result of this term, crosses over to the other side. And I have negative 2a plus b is equal to negative 8. Now, let me call that equation 1. In the same way, similarly, let me plug 1 into p of x and equate it to 0. So we're having 1 cubed, I add 4 into 1 squared, I add a into 1, then plus b is equal to 0. Simplifying and multiplying out the exponent as well, I get 1, then plus 4 plus a plus b is equal to 0. Simplify everything here, I have a plus b is equals to negative 5. Now, what I'm left to do is just to solve equation 1 and equation 2 simultaneously for the values of a and b. Now, let me solve the two equations. Let me write those equations down, and I'll be having negative 2a plus b is equal to negative 8, and a plus b is equal to negative 5. Notice that the coefficients of b in both equations are the same. So if I subtract these two equations, b will vanish. So let me subtract equation 2 from equation 1. So 1 minus 2, I'll subtract negative 2a minus a, negative 3a. Then negative 8 minus negative 5 is negative 8 plus 5, which gives me negative 3. And when I divide both sides by negative 3, I have a to be 1. I'll just take this 1 and plug it back into equation 2. So I'll be having b will be equal to negative 5 minus a, and a is 1. So I have b is equal to negative 5 minus 1. So b gives me negative 6. So I have the values of a and b. I'll go back to the polynomial and plug in those values. P of x will give me exactly this polynomial. So I am done with the first part of the question. Now the next part of the question is that I have to factorize P of x completely. When we are asked to factorize a polynomial completely, what they're asking us to do is that let us try to write the polynomial as the product of its linear factors. So here I will take P of x and I will divide by the factor that was given to me in the question. To factorize P of x completely, we are required to write P of x as a product of its linear factors. So we will perform long division by dividing P of x squared plus x minus 2. Now, performing long division, you are going to have the remainder as 0 and the quotient x plus 3. So if you have a problem performing long division with polynomials, then leave a comment below. I'll find time to come and explain how you can perform this long division. But by the way, dividing, this is what we have as result. Now that we have divided P of x by the divisor and we have a quotient, then I can write P of x as the product of the divisor and the quotient. Think of this. If I take 18 and I divide by 9, my result is 2. How can I write 18? I can write 18 as the product of 9 and 2, because multiplying 9 by 2 is going to give me 18. So that is how we have written P of x as a product of its divisor and its quotient. So if I expand this, I'll come back to P of x. Now we were told to factorize it completely, and from the start of the question I already factorized this quadratic expression. So I'll just plug it in. I'll have P of x is equals to x plus 2 into x minus 1 into x plus 3. So I have factorized P of x completely. I hope this first part is understood. So if there is any question, then leave it in the comment section. Now let's move on to the second part. The second part of the question is, show that for real values of x squared plus 2x minus 11 divided by x minus 3, where x cannot be 3, cannot take values between 4 and 12. So they're asking us to show that this expression here cannot take value between 4 and 12. Now to solve the problem, I will let y to be that expression, and I will try to show that y, which is this expression, cannot take values between 4 and 12. Now I will just rearrange it into a quadratic equation that has y. So I have to show that y cannot lie between 4 and 12. So let me reorder it by cross multiplying. Y multiplies into x minus 3 is equal to this expression just multiplies 1, the denominator of y, and gives me this. Multiply out the bracket, I have xy minus 3y is equals to x squared plus 2x minus 11. Now let me take all terms to one side of the equation. So I'll be taking this expression to the other side of the equation. So I'll be having x squared plus 2x, then xy goes the other way and becomes negative xy, then negative 11 will still be there, then this term cos 3y is equals to 0. Notice that these two terms are terms in x, so I can factor out x from this expression. Then I'll be having x squared plus 2 minus y into x minus 11 plus 3y is equals to 0. Now I have expressed it in form of a quadratic equation in x, of course. Here, a will stand for the coefficient of x squared, which is 1. B will stand for the coefficient of x, which is 2 minus 1, 2 minus y, and C is a constant term, the term without x. Now, what do we know? We were told that for real values of x, that means x is real. And we know that for real values of x, b squared minus 4ac, which is the discriminant of that quadratic equation, must be greater or equal to 0. Now I'll plug in the values of a, the values of b, and the value of c into this expression. And so I'll be having 2 minus y, all that squared, because that is b, minus 4 into a1 into c, which is negative 11 plus 3y, is greater or equal to 0. Expanding this, I have 4 minus 4y, then plus y squared. Negative 4 into negative 11 gives positive 44. Negative 4 into positive 3y gives negative 12y, is greater or equal to 0. Bringing like terms together, I will be having y squared, which is the other term in y, then minus 16y, because negative 4y minus 12y give us negative 16y, and 4 plus 44 is 48. Now let me factorize this quadratic equation in y, this quadratic inequality in y, so that I can be able to solve. Now factorizing, I have two factors. Of course, the factors are negative 4 and negative 12, because the product of negative 4 and negative 12 is 48, and their sum is negative 16. So factorizing this quadratic expression on the left hand side, I get this. Now, what is the question here? The question here is, I am looking for the range or the set of values for y, for which the left hand side is always greater or equal to 0. In other words, I'm looking for the range of values of y for which the left hand side is always positive. Because if we say a number is greater than 0, we are in other words saying that that number is positive. So to do that, I will start by finding the critical or the boundary values. I will take each one of these linear terms equate to 0 and find the value of y, and find the value for y. Y minus 4 is 0, means y is 4. Y minus 12 is equal to 0, means y is 12. So these are the critical values, the values for which each of these terms will vanish, or the boundary values. Now the boundary values is going to help us to create set, or to create some ranges of values for y, in order to find the range for which those values will satisfy this inequality. Now, a sign table will give us a range of values of y. There are many ways to draw the sign table, but I will use one of the easiest ways, which is just drawing a number line and indicating those critical values as they appear on the number line. So I'll have a number line, then the critical values are 4 and 12. Of course, 4 is less than 12, that is why 4 is on the left and 12 is on the right. Now, I have 3 intervals to test for the values of y, to test for the sign of y. The first interval is that I will take any value of y which is less than 4 and test for the sign only. Remember, I'm looking for the set of values for which the left hand side is positive. Then next, I will pick any value between 4 and 12 and also test for a sign. And finally, I will take a value which is greater than 12, plug it in here and test for a sign. At the end of the day, then those intervals whose signs are going to be positive are those intervals which will satisfy that inequality. Now let us begin with that. Think of any number which is less than 4. I will think of 2. You can think of any one as long as it's less than 4. Let me take 2. Then unplug it anywhere I see y. 2 minus 4 gives me a negative value. I'm concerned only about the sign, so I can leave out the number itself. So 2 minus 4 is negative. Then 2 minus 12 is negative. So if I'm looking for the product of these two terms. Negative multiplied by negative gives positive. That is why, so if I take any value within this interval, I will always have positive. Now let me come in the interval between 4 and 12 and think of any number. What number can you think of? Let me think of 5, because 5 is of course between 4 and 12. If I plug in 5, 5 minus 4 gives me a positive number. 5 minus 12 gives me a negative number. I'm finding the product of these two terms. Positive multiplied by negative gives me negative. So this interval is negative. So any value I'll pick within this interval, I'll have a negative value. About in the interval greater than 12, let me think of a number. 10,000, of course. 10,000 is large, but it is a valid number. Let me take 15. 15 minus 4 is positive. 15 minus 12 is positive. Positive number multiplied by a positive number gives me positive. So these are the range of values. I need to go back to my inequality and see which range of value am I going to select based on the inequality. So I will see that the inequality is this left hand side needs to be positive, and so these are the intervals satisfying those inequalities. So positive, positive, and this one is negative. I don't need that. So the range of values for y is that y is less than negative 4 and y is greater than 12. So let me go back. Then, so these are the required inequality for the values of y. That means y cannot take values between 4 and 12, and that was the question. So from the sign table above, y can only take values in the solution set. Y is less than or equal to negative 4, and y is greater or equal to 12. So y cannot take values between 4 and 12. And we've answered that question. Now, the next part of the question, question 2, was on functions and combinations. So let us go to the first part. Let us go to the first part, which is functions, question 2. The root of the quadratic equation x squared minus 3x plus 2 is equal to 0 are alpha and beta. Find a quadratic equation whose roots are alpha plus 2 over alpha and beta plus 2 over alpha. I think here should be alpha plus 2 over beta. So here is beta. It's just a typing error, but I think it will be fixed in the next as we'll be solving. What do you need to know? If the root of the equation x squared plus bx plus c is equal to 0 are alpha and beta, then the sum of the roots, which is alpha plus beta, would be negative b over a, and the product of root alpha times beta will be c divided by a. This is the first thing you need to know. Then what else do you need to know? If the root of any quadratic equation are alpha and beta, then we can form the equation from which these roots were obtained using x squared minus alpha plus beta multiplied by x, then plus alpha beta is equal to 0. In other words, we can write x squared minus the sum of those roots. SONR here stands for sum of new root, but it doesn't matter. X squared minus the sum of those roots, then plus the product of those new roots or those roots is equal to 0. So you have to know this before you face this problem. Now, let us move on to the problem itself and solve. As you can see, I have corrected it in the next slide of this presentation. All right, let us move on. This is the equation. X squared minus 3x plus 2 is equal to 0. And what are the roots alpha and beta? So we need to go ahead and we write out the new root because we have been asked to form an equation with this new root. So let me take the root of this equation and find the sum of those roots. Sum of the root, we are taking negative of the value of b divided by a. Negative into negative 3 divided by 1, which gives me 3. So the sum of those roots is 3. Now, what about the product of the root? Alpha and beta. Remember, I'm taking the root of the equation that was given to me. Alpha times beta, which is equal to c divided by a. 2 divided by 1 gives me 2. Now, I have the sum of the root of this equation and I have the product of the root of this equation. But I want to form a new equation with these new roots. So the next thing to do is to find the sum of the new roots. So I will take these two roots and sum them. So I'll be having alpha plus 2 over beta then plus beta plus 2 over alpha. Then I will bring these two terms together, alpha plus beta, because I know its value as 3. So I'll be having alpha, then I'll be having alpha plus beta, then plus, I'll find the LCM of these two fractions. Of course, the LCM of alpha and beta is alpha beta. Alpha beta divided by beta give alpha times 2, 2 alpha. Alpha beta divided by alpha beta times 2, 2 beta. So the next thing to do here is that 2 is common to the numerator. If I factor out 2, I'll be left with alpha plus beta divided by alpha beta. And of course, I know the value of alpha plus beta as 3, and the value of alpha times beta is 2. So I'll just plug in those values, and I'll be having the sum of the new root. When I plug in the values, this is what I get. I'll have this 3. I add it to 2 into 3 divided by 2, because alpha plus beta is 3 and alpha times beta is 2. This 2 strikes out. I'll have 3 plus 3, which is equal to 6. So the sum of the new root is equal to 6. Up next, I find the product of new roots. I just take this new root and multiply them. So I'll multiply out the bracket. Alpha times beta, alpha beta. Alpha times 2 over alpha gives 2, because alpha cancels out with alpha, I'm left with 2. Then 2 over beta times beta, beta cancels out, I'm left with 2. And 2 over beta times 2 over alpha, 2 times 2 gives 4. Beta times alpha gives beta alpha, or better still, alpha beta. And I know what alpha beta is. The value is 2, because alpha beta is the same with alpha times beta, 2. Then just plug in the values and simplify. 2 plus 4 divided by 2. That gives 2 plus 4, 6 plus 4 divided by 2 is 2. 6 plus 2 gives 8. So I have the values of the product of new root as 8. Now I'm done. So I can form the new equation by writing x squared minus the sum of the new root, which is 6, and I add the product of new root, which is 8, and I equate it to 0. So this is a new equation which we have formed. I hope it's understood and is clear. So I'm waiting for questions or comments in the comment section below. I'll make sure that I go through the comment and I see how I can be able to answer your questions. Then the second part of question 2 is find the values of k for which the root of the equation x squared plus kx minus 2x plus 2k plus 1 is equal to 0 are equal. What do you need to answer this question? You need to know that if the quadratic equation ax squared plus bx plus c equals to 0 has equal root, then the discriminant is equal to 0. That is all you need to know. What is discriminant? B squared minus 4ac is equal to 0. So this is what I need to use in order to find the values of k. So I have some work to do. I need to rearrange the equation so that it can be written to rearrange this equation to look like the standard form of a quadratic equation. So notice that these are terms in x. So x is common. I can factor out x. If I put x as a factor, the coefficient of x is k in the first term, and the coefficient of x in this second term is negative 2. So I'll be having k minus 2 multiplied by x. Then I add 2k plus 1 and equate to 0. Now it is in the standard form of a quadratic equation, where a is 1, b is k minus 2, and c is 2k plus 1. So I'll just take in the values of a, b, and c and plug them into this quadratic and plug them into the discriminant and equate to 0. So for equal root, b squared minus 4ac is 0. We have seen that already. So I'll just plug in the values. What is b? K minus 2. So k minus 2 all that squared minus 4a is the coefficient of x squared, which is 1, because 1 is multiplying x squared, then into c, and c is 2k plus 1. So I have 4 into 1 into 2k plus 1 is equal to 0. I just have to expand this, and expanding or multiply out the bracket, k squared minus 4k plus 4, negative 4 multiplies 2k to give negative 8k, negative 4 multiply 1 to give negative 4. Then let me rearrange this in the quadratic form. I have k squared, then negative 4k minus 8k, negative 12k, 4 minus 4 gives 0. This is what I have. Now, most of you will be tempted to divide all through by k in order to find the value of k, but that will not be mathematically just, because if you divide all through an equation by the variable which you are looking for, then you will lose one of those solutions. So instead, I'll factor out k from these two terms. K is a factor, so I put k as a factor. K squared divided by k, I have k. Negative 12k divided by k, I have negative 12 is equal to 0. So in this case, I can now apply the null factor law, which states that if the product of two terms is 0, it implies that either of the terms is 0. So either k is 0 or k minus 12 is 0. So k will be equals to 0, and if I equate k minus 12 to 0, negative 12 goes the other way and k gives me 12. So these are the values of k. K is equals to 0 or k is equals to 12. Notice that if I had divided this equation by k, I'll be having k minus 12 is equals to 0. I'll have just one value of k, which is 12, and I'll lose the other value, which is 0. So avoid dividing an equation by the variable which you are looking for. I hope it's understood. Let's move on to the next question. A question on combination. A committee of 5 people is to be selected from 5 men and 7 women. In how many ways can this be done if the committee must contain more men than women, with at least one woman included? Now, there are a lot of things here to look at. They're asking us to form a committee, and conditions have been given. The committee, we want to form a committee of 5 people, and from 5 men and 7 women. So they have altogether 5 men and 7 women. In how many ways can this be done if the committee must contain more men than women, with at least a woman or one woman included? So these are the key words that we need to be careful with. So to solve this, I will make it easy by representing the solution or the approach on the table. So I'll put that on the table. And the first column of the table will be men, the second will be women, and the third column will be the total. So how many men do we have? We have altogether 5 men. How many women are we having? 7 women. Then, what is the number of persons in the committee we want to create? We want to form a committee with 5 people. And what are the conditions? The conditions are that there should be more men than women, with at least one woman included. Now, what are the possible ways by which we can form a group with these conditions? Now, the first way is that I can select 4 men from 5 and 1 woman from 7. If I add them, I'll have 5, and the condition is fulfilled because here there are more men than women and there is at least a woman included, and the total sum of these persons gives me 5. So these are just one of the ways by which I can form that committee. Now, what other way can I form that committee with the conditions given? I can select 3 men from 5 and 2 women from 7. The conditions still are fulfilled because 3 is more than 2. There are more men than women, and there is at least a woman included. At least means the minimum number of women should be 1 going upward. So if I add 3 plus 2, I get 5. So this is another possibility of forming that committee. Is there anyone? think if we still have another possibility. Of course not, there isn't, because if I want to go ahead, then the men will have to drop by 1 to 2 and the women will go up to 3, which is going to be against the condition because the men will not be more than the women anymore. If I take up the men to 5, I have to select no woman, which is against the condition because at least a woman should be included. So these are the only 2 possible ways by which I can form a committee with 5 people with the conditions given in the question. Now, how then do I use these conditions to arrive at my answer? Total committee will be 5 combination 4 times 7 combination 1. I add 5 combination 3 times 7 combination 2, which gives me 245. So what am I writing? 5 combination 4 times 7 combination 1. Why am I multiplying? Because the event of selecting a man and selecting a woman are independent. They don't depend on each other. The occurrence of one or non-occurrence of one does not in any way affect the occurrence or non-occurrence of the other. That is why I am multiplying them. Or this other possibility, or can be translated to plus because I'm adding. The 2 possibilities are mutually exclusive. They cannot occur at the same time. Either I have this first possibility or the second possibility. What about the second possibility? I select 3 men from 5 and 2 women from 7. Then if I punch this in my calculator, it will give me 245. Now, this is what we have done. The event of selecting the men from 5 and the women from 7 are independent. The reason why we multiply their possibilities, the reason why we are multiplying them. The 2 possible events of selecting the men and the women for the 2 situations are mutually exclusive. So these 2 situations are mutually exclusive. That means they cannot occur at the same time. Reason why we add their possibilities. So this is generally how we approach questions concerning combinations with conditions attached to it. You draw a table and you try writing out all the possibilities that can exist. Then from there, you'll be able to see which of the events are independent. You multiply their possibilities and see which are mutually exclusive. You add up their possibilities in order to arrive at your answer. Now, the next question, question 3 is on functions and binomial expansion. First question, functions. The functions f is such that r except -2 is mapped onto r is defined by f of x is 3x minus 5 divided by x plus 2. Show that f is not surjective. So we are asked to show that this function is not surjective. A function is the relationship between 2 sets where one set is the domain and the other set is a codomain. The elements in the domain are mapped onto elements in the codomain. So in this function, f is a function and r minus -2, which can be interpreted as all the set of real numbers except one element, which is -2. And this first set forms what we call the domain. And elements from the domain are mapped onto elements from the codomain. So the set of real numbers is a codomain with no exception. Now, this is the function. What do you need to know? A function is surjective when the range of the function is equal to its codomain. That is, if f is surjective, then the range of f is equal to the codomain of f. So in this case, since f is not surjective, and I asked us to show that, then we are required to show that the range of f will not be equal to the codomain of f. Now let me go to the question and let me let y to be f of x. Then so I can write y is equals to 3x minus 5 divided by x plus 2. Then multiplying, cross multiplying, I have y into x plus 2 is equal to 3x minus 5. Multiply out the bracket, I have xy plus 2y is equal to 3x minus 5. Let me make x the subject of this equation. So I'll bring terms in x together. So I'll be having xy, this term in x moves to the left hand side, minus 3x is equals to, I'm left here with negative 5 minus 2y. X is common, let me factor out x, and x will be equal to y minus 3. So I factor out x and I get y minus 3 is equals to negative 5 minus 2y. Dividing both sides by y minus 3, I have x is equals to negative 5 minus 2y divided by y minus 3. So we see that y can take all values except when this denominator is 0. So to find the range of the function, of a rational function, just equate the denominator to 0. Y minus 3 is equal to 0. You will see that y is equal to 3. So that means the range of this function is y can take all real numbers except one element, which is 3. And we see that this is the range of the function and this is the codomain of the function. So the range of that function is not equal to, is different from R, which is the codomain. Then f is not surjective. But had it been that the range of the function was exactly equal to the set of real numbers, then we would have said the function f is surjective. I hope it's understood. Let's move on to the second part of the question, which is binomial expansion. Show that if x is so small that x cubed and higher powers can be neglected, then the square root of 1 minus x divided by 1 plus 2x is approximately equal to 1 minus 3 over 2x plus 15 over 8x squared. Hence, find to 3 decimal places an approximation for square root of 99 divided by 102. So this question is in two parts. We have to show this first, then when we have the result, or we use this result and we find an approximation to the square root of 99 divided by 102. All right, what do you need to know? So if n is a rational number or a fraction and x is a real number where the absolute value of x is less than 1, then this expansion is approximately equal to this. So 1 plus x raised to the power n is equals to 1, then plus nx, and all of this. So this is what the expansion is. So in order to apply this expansion for what has been given to us, we need to rewrite this expression in this form so that we can apply this formula and plug in the values of x and n, of course, and obtain the expansion of that expression. So what we have to do is that we have to play a little bit by rearranging or reordering this expression in order to make it look like what is in this expansion, like what has been expanded to obtain the right hand side. So we know that the square root means we are raising a number to the power half. So all of this is the same as 1 minus x divided by 1 plus 2x, all that raised to the power of half. So we can distribute the exponent amongst the numerator and the denominator, and we get 1 minus x raised to the power a half divided by 1 plus 2x raised to the power a half. Of course, we can apply indices, and we take the denominator to the numerator, and the sign on the exponent will change from positive a half to negative a half. So that means after doing the manipulations, this is what you get. 1 minus x raised to the power a half into 1 plus 2x raised to the power negative a half. So what are we supposed to do now? So this can be compared to this binomial expansion. I will expand each of these terms and then multiply out their bracket with the hopes of obtaining what have been asked in the question. So I will take this first part, expand, take this second part, expand, and then multiply them out to see if I obtain what I've been asked of the question. Now, 1 minus x raised to the power a half is the same as, remember, if I compare this, then I will see that x in this expansion is negative x because the sign is very important, and n is half. So I will just replace anywhere I see x, I replace by negative x, and anywhere I see n, I replace by half. So the first term must be 1. I have 1. Then n times x, so I multiply half times negative x, that gives me negative half x. Then I add it to n, which is half, n minus 1, half minus 1 is negative half, negative x, so x squared, and x is negative x all that squared, divided by 2 factorial. Then notice that I've ended somewhere here. Why is it so? Because the question tells me that x is so small that x cubed and higher powers can be neglected. It means x cubed and the powers above x are so small that we can ignore them. That is why I stopped at the level of x squared and I did not continue, because the question tells me that they can be ignored. So I will just simplify this, and when I simplify, I have negative half x. Everything simplified here. Remember, 2 factorial is 2 times 1, which is 2. So, and when I multiply negative x squared, it gives me positive x squared. Then half times negative half gives me negative 1/4 divided by 2, which is negative 1/8. So the first expansion gives me this. Moving on to the second expansion, which is 1 plus 2x raised to the power negative a half. I do the same thing, but replacing x with 2x and n with negative a half. So I'll be having 1 n times x, that is negative a half, into x, which is 2x, then negative a half into n minus 1, that is negative half minus 1, gives me negative 3 divided by 2, x squared. X is 2x, 2x all that squared divided by 2 factorial. Simplifying, the first term is 1, then 2 strikes off with this 2, I have negative x. Simplifying everything here, I'll have 3 over 2x squared. Remember that 2x squared here will give, remember that 2x all that squared after the expansion will give you 4x squared, because this exponent affects each term within the bracket. 2 squared is 4, x squared is x squared is x squared, so it gives you 4x squared. So simplifying all of this will give you 3 over 2x squared. Now that I have these 2 expansion, I have to plug it back here and multiply out that bracket. So this the square root of this expression would be the product of this expansion. So I'm eventually expanding 1 minus half x minus 1 over 8x squared into 1 minus x plus 3 over 2x squared. Let us do the expansion together. 1 times 1 gives us 1. 1 times negative x gives us negative x. And then 1 times 3 over 2x squared gives us 3 over 2x squared. Let me move on to the next term, which is negative half. Negative half times 1, negative half. Negative half times positive. Okay, let me take the multiplication all over again. 1 times 1 is 1. 1 times negative x. 1 times 3 over 2x squared gives me 3 over 2x squared, the same thing. Move on to the next one, which is negative half. Negative half times 1, negative half x. Negative half x times 3 over 2x squared. Multiply x times x squared gives me x cubed, which we have been told that let us neglect all powers of x cubed or higher. So that is why I've ignored that term. Negative 1 over 8x squared times 1 gives me negative 1 over 8x squared. Negative 1 over 8x squared times x, that is what they determine x cubed, and I ignore it. Negative 1 over 8x squared times 3 over 2x squared, that is what they determine x fourth, I ignore it. So this is the expansion after ignoring all terms of x cubed or higher, all powers of x cubed or higher, this is what I get. What I'm left to do now is to bring like terms together. I only have one constant term, which is 1, so I can't add it to any other term. Then I have two terms in x, negative x minus half x. These are terms in x, so I just subtract their coefficients, or I bring their coefficients together. So I have negative 1 minus 1 all over 2. Then that gives me negative 3 divided by 2x. This term is a term in x squared, this is a term in x squared, and this is a term in x squared. So I have to bring them two together, so I will just add their coefficient. I will take 3 divided by 2, I add it to half, and I subtract 1 divided by 8. Punching that on the calculator will give me 15 divided by 4x squared. And we have 15 divided by, it's supposed to be by 8x squared. So try it again and see. So it's 15 divided by 8x squared. So we have come out with that expansion. So we have the expansion. So punch it on your calculator and it will give you 15 divided by 8 and not by 4. So this, of course, is supposed to be 8. It's supposed to be 8 and not 4. All right. So that being said and done, let's move on to the next slide. Now, the next part of the question is to show that if x is so small that x cubed and higher powers can be neglected, then this is equal to this. We have shown that already. Hence, find to 3 decimal places an approximation for the square root of 99 divided by 102. Okay, so we have to go ahead to solve the problem. And what do we need to know? We need to compare the expansion with the square root of 99 divided by 102 in order to find the value of x, which will be valid for the expansion, and then substitute into the expansion to obtain the approximate value. So we know that this expansion is approximately equal to what we have on the right hand side. Of course, this is 8 and not 4. That is just a typing error. This is 8. Now, what does that mean? It means that if we compare the left hand side, which is the square root of 99 over 102, I will say is equivalent to 1 minus x divided by 1 plus 2x. Why am I equating this? Because I have to use this expansion to find the approximate value of the square root of this quantity. So if the left hand side is equivalent to the right hand side for some x, then I have to equate them and find the value of x. So I'll look for that value of x, which is valid for that expansion, and then substitute it back into this expansion to obtain the approximate value of the square root. So what am I supposed to do here? So what I have to do is I will solve for the value of x. Squaring both sides, I'm left with 1 minus x divided by 1 plus 2x is equal to 99 over 102. Then I'll cross multiply and find the value of x. It's pretty easy. I will just be very fast with the multiplication. So when I multiply, then I have 1 times 102 gives 102. Negative x times 102 gives negative 102 times x. 99 times 1 gives 99. 99 times 2 gives 198 x, of course. Let me bring the x terms together. I have negative 300 x equals to negative 3. Dividing both sides by negative 300, I have x is equals to 0.01. So that means the left hand side is equivalent to the right hand side for some value of x, which is 0.01. That means if I come back to the expansion that I had solved before and I substitute x by 0.01, I will be finding the square root of 99 divided by 102. So let me go back to this expansion and substitute in the values of x. So I'll be having the square root of 99 divided by 102 is equal to 1 minus 3 over 2 multiplied by that value of x, which I have it as 0.01. Then plus 15 divided by 8, not 4, please, this over 8, into 0.01 all that squared. Then Doing the maths, you are going to have 0.985 to 3 decimal places. You can use your calculators and compare and punch, and then you punch the square root of 99 over 102 and also evaluate this and compare the result. You will see that the results are exactly the same to 3 decimal places. Now, question 4 is trigonometry. Let's move on to trigonometry and see how we can solve that problem. Show that cos 2 theta is equals to 1 minus tan square theta divided by 1 plus tan square theta. Let us show this. You have a choice. You can either take the left hand side and you show the right hand side, or you take the right hand side and show the left hand side. The choice is entirely yours to decide on. But you have to be wise. You have to take a side which is easier to show the other, because in some cases it is not always easy or obvious to take any side and come back to the other side. So in this case, the two sides are almost the same, but I'll be using the left hand side to show the right hand side. So what do you need to know in order to leave from the left hand side and arrive at the right hand side? What do you need to know? First, cos 2 theta is equal to cos square theta minus sin square theta. So this is a trigonometry identity which you know, and I think it is in your formula booklet as well. Then the next thing you need to know is that cos square theta plus sin square theta is equals to 1. If you find cos of an angle and square it and add it to the sine of and add it to the square of the sine of the same angle, your answer will be 1. Then what again? Tan theta is the same as sin theta divided by cos theta. Now let me take the left hand side. The left hand side is cos theta. Cos 2 theta, I mean to say cos 2 theta. Cos 2 theta here. Now cos 2 theta is cos square theta minus sin square theta. But what I want to show is a fraction. So I can rewrite it as a fraction by dividing it by 1. Because dividing a number by 1 does not change its value, but it makes it a fraction. So then how can I write 1? Of course, this trigonometry identity tells me that cos square theta plus sin square theta will always give me 1. So I can replace it by cos square theta plus sin square theta. And this is already showing that I'm on the right track, because what I want to show has 4 terms. 2 terms on the numerator and 2 terms on the denominator. And this is exactly what I have. What can I do with this in order to obtain this? By using mathematical rules in order to arrive there. Then this first term is 1. And the term in the numerator as well is 1. How can I make this 1 without cheating? Using mathematically justified steps. I can divide cos square theta by itself, because cos square theta divided by itself will give me 1. But because in mathematics we have to do that for all, and then we have to justify our steps, I will divide each term by cos square theta, which they can cancel out, and it means I've changed nothing in the question. So dividing each term by cos square theta, we have cos square theta divided by cos square theta is equals to sin square theta divided by cos square theta is equals to divided by cos square theta divided by itself plus sin square theta divided by cos square theta. I've divided each term by cos square theta. Those terms could still cancel out, and you come back to exactly the same expression. Now, cos square theta divided by itself is 1. Sin square theta divided by cos square theta is tan square theta. Then this term also gives me 1. Sin square theta divided by cos square theta gives tan square theta. And this is a right hand side. So, as required. So, I've shown the first part. Now, question 4, Roman 2. 2 cos into 3x minus pi on 3 can be expressed in the form a cos 3x plus b sin 3x, where a and b are positive constants. That is real constants. A, find the values of a and b. Hence, find B, the general solution of the equation A root 2 cos 3x plus B root 2 sin 3x is equals to 2. Now, what do you need to know? Cos A minus B is equivalent to cos A cos B, then you add it to sin A sin B. So this is a trigonometry identity which is found in your formula booklet. And of course, when you solve regularly, you know it offhand. You must not open your formula booklet all the time to check them. So that is it. Now, A cos 3x plus B sin 3x is equivalent to 2 cos into 3x minus pi on 3. Now, this is equivalent to this. So I've taken the left hand side and I've equated it to the right hand side. How can we find the constant A and B? What we need to do here is to expand the right hand side, to use our idea of compound angle identity, what I've just written down here, and expand the right hand side and use it to compare them with the left hand side in order to find the values of A and B. So I will expand using this expansion which I've written below. So I'll be having 2 into cos 3x cos pi on 3, then sin 3x sin pi on 3. I add them. So this is what I have. But cos pi on 3 is the same as cos 60 degrees, and sin pi on 3 is the same as sin 60 degrees. So evaluating, cos 60 degrees gives me half, and sin 60 degrees is root 3 divided by 2. So I would love to put these coefficients before. I would love to put these coefficients ahead, so that when you multiply out the bracket, 2 takes care of this 2. I have cos 3x. Then 2 takes care of this other 2. I have root 3 sin 3x. So you see that the left hand side is equivalent to the right hand side. And I have terms in cos 3x and sin 3x. So at this step, I'll compare corresponding coefficient of cos 3x and sin 3x. So coefficient of cos 3x on the left hand side is A, while the coefficient of cos 3x on the right hand side is 1. So A is equals to 1. The coefficient of sin 3x on the left hand side is B, while the coefficient of sin 3x on the right hand side is root 3. So we can say B is equals to root 3. So A is 1 and B is root 3. So we have had the values of A and B. Question, hence, let's find a general solution of this trigonometry equation is equal to 2. So what we need to do here is that since we can express this expression in terms of cos, we need to know the general solution for cos x. The general solution for cos x is given by x is equal to plus or minus the principal value, then plus 2 pi n, where n is an integer. So you need to find the principal value of that cosine equation and then add it to 2 pi n, where n is an integer. So this is what I have to solve. And I have the values of A and B. Let me plug the values of A and B. So I can factor out root 2. Root 2 goes out because root 2 is common to these two terms. And A was 1. So 1 times cos 3x leaves it unchanged. B as root 3. So I have root 3 into or times sin 3x equals to 2. And remember, this expression is equal to 2 cos into 3x minus pi on 3. So, but then I can divide both sides by root 2, and I have this, and the left hand side is exactly equals to, and the left hand side is exactly equals 2 cos into 3x minus pi on 3 is equals to 2 divided by root 2. I can divide each term by 2. The 2 cancels out, so I have 1 divided by root 2. Then finding the cos inverse of both sides, I get what they call the principal value. So I will just use the general solution at once. So I'm left with 3x minus pi on 3 is equals to plus or minus that principal value, the value of the angle which I obtained by finding the cosine of both sides of the equation. So the cosine of 1 over root 2 will be the principal value. That's why I'm writing plus or minus of cosine of 1 over root 2 plus 2 pi n, where n is an integer. So I just have to take all the terms to the right hand side and make x the subject of the equation. So I can start by taking negative pi on 3 to the right hand side. It becomes positive, and I divide both sides by 3, or I multiply each term by 1/3. Multiply each term by 1/3, I have x is equals to pi on 4 times 1/3 gives pi on 12. So plus or minus pi on 12. 2 pi n times 1/3 gives 2 pi n on 3. Then pi on 3 times 1/3 gives pi on 9. So this is the general solution of that trigonometry equation. Of course, n is an integer. I hope you are with me here. So if you still have some questions or doubts or worries, you can drop them down there in the comment section, and I'll make sure that I try to answer them to your understanding, to the most of your understanding. So question 5, we are going to end up with this question. So be patient while we look at the proposed solutions for this question. We will be linearizing an equation. So question, this question 5, not 4. The table shows corresponding values of x and y. Which approximation satisfies a relation of the form y is equals to ln ax plus b? And this is a table. We have values of x in the first row and values of y in the second row. By drawing a suitable linear graph, determine to one decimal place the values of the constants a and b. So this is the equation that governs this set of values, and we have been told to use this equation and draw an appropriate linear graph from where we can obtain the values of a and b. What do you need to know? A straight line can be written in the form y is equals to mx plus c, where x and y are the general points on the line, m is the gradient of the line, and c is the intercept of the line with the y-axis. So all straight lines can be written in this form with 3 terms. So what we need to know, the skills we need to know here, is that we should be able to linearize this expression by writing it in this form. And of course, this c term is a constant. That means it can be 0, and if it's 0, you are going to have y equals to mx. It cuts the y-axis, but it cuts it at the point 0, so it passes through the origin of the graph. Okay, that being said, let us move on. Now, y is equals to ln of ax plus b. What most students would do here, which is not agreeing with the laws of a log, is that they will multiply out the bracket. Please don't do that. That is not in agreement with the laws of logarithm. So what we can do instead is that let us try to eliminate this ln from the right hand side. And how can we do that? Let's think of the inverse of the logarithmic function, which is of course the exponential function. So I will take e on both sides of the equation. So I have e to the y is equals to, when I take e of the right hand side, e is the inverse of ln, so they take off each other. I have just ax plus b after taking e on both sides. Means e to the y is equals to ax plus b is in the form y is equals to mx plus c. So this equation now has been written in this form. So this is what I'm going to plot on the y-axis, because I'm comparing it with the standard form of the equation of a straight line. So a corresponds to m, so a is the gradient of that line, and b corresponds to c, so b is the point where the line cuts the y-axis. Plotting a graph of e to the y on the y-axis against x on the x-axis will be a straight line with a gradient a, and b will be the intercept with the y-axis. So that being said, let us go ahead and then modify the table by finding values of e to the y, because this is what we will be plotting on the y-axis and not these values of y, because this equation has been linearized into this equation, and this is what we are using to draw a straight line from where we can obtain values of a and b. So evaluating e to the y, we obtain the following values on the table. So you can use your calculators and evaluate e raised to the power y. So when y is 1.4, e raised to the power 1.4 gives us 4.05. Let me write my values to 2 decimal places for now. I will bring it back to 1 decimal place, of course. Now, when y is 1.6, I substitute, I get 4.95. When y is 1.8, I substitute, I get 6.04. When y is 1.9, it's e raised to the power 1.9 gives me 6.69. Y is 2.1, e raised to the power 2.1 gives me 8.17. Y is 2.2, e raised to the power 2.2 gives me 9.02. So these are the modified values of y, what are plot on the vertical axis, of course using the equation which I have obtained. Now this is a graph that I'm going to use to plot those points and those values on. So the next thing I need to do is to draw my axis. I have a vertical axis, of course, e to the y, and against x, the horizontal axis. Up next, I need to choose a scale. So on the x-axis, I've chosen a scale of 2 centimeters for 1 unit. So as you can see, I've counted 2 squares for 1 unit, 2 squares for 1 unit. So what is the precision? The precision means what is the smallest value that I can plot on the x-axis. Remember, each of these boxes has 5 subdivisions. So if I take 2 boxes for 1, that means I'll take 1 and share it amongst 10 subdivisions, and 1 divided by 10 gives 0.1. So on this x-axis, my precision is 0.1, not 1, 0.1, because that is the smallest value I can plot on the x-axis. Now moving on to the y-axis, I have used 1 square for 1 unit. So what is my precision? My precision is 1 divided by 5, because there are 5 subdivisions, and 1 divided by 5 gives me 0.2. So that is the least value that I can plot on the y-axis. Very important. Now that I have my scale and my precision 0.1, the scale on the y-axis and my precision 0.2, I can go ahead now and plot my graph with ease. So these are the values that I want to plot. I have rounded them off to 1 decimal places. So let me start and plot. When x is 1, e to the y is 4. So this is x is 1, e to the y is 4. This is where the vertical and the horizontal lines meet. So this is the point 1, 4. Then when x is 2, y is 5. X is 2, y is 5. So this is the point. Now let's move on to the next point. X is 3, y is 6. X is 3, y is 6. So this is the point. X is 4, y is 6.7. Now the position comes now into play. X is 4, y is 6.7. This is 6. And each of these sub-square is 0.2. 6.4. So 6.2, 6.4, 6.6. So 6.7 is in between 6.6 and 6.8. So I round it off to 6.8. So I plot it at 6.8. So x is 4, y is 6.8. Because we don't plot inside of those boxes, we plot only in order to obey the precision. In order to obey the precision. Now the next value is x is 5 and y is 8.1. So I'll plot it at 8.2. I round it up. So 8.2. Then finally, x is 6, y is 9. So this will be somewhere here. X is 6, y is 9. So I have the point here. Now at this point I have to draw what they call the line of best fit. What is the line of best fit? That is the line that separates equal number of points above the line as there are below the line. So if I draw a line that will balance only on the most number of points without separating the points equal separation above as they are below, then that is not the line of best fit. It has to balance the points. And most often it is difficult, it is rare that you plot a graph that all your points fall on the same straight line, because there are always random and systematic errors. So you have to be used to the skills of drawing the line of best fit is mandatory under this particular topic. So I will try to draw a line that will balance up equal points above the line as they are below the line. So this is my line of best fit. Now notice that these 2 points seem to fall below the line and these other 2 points seem to fall above the line. So the line has been balanced in such a way that it separates equal points above as they are below. So this is what they call the line of best fit. So now that you've drawn the line of best fit, we have now to draw a right angle triangle in order to find the gradient. So I'll draw it from here to here. Avoid drawing it from points that you have plotted, because it may not give you a reliable answer. So draw it from neutral points on the line. So I've chosen points that are neutral. So let me write out their values. So this is the value here. I have x is 1.5 and y is 4.4. Then at this point x is 4.5, y is 7.6. So I have 2 points on the line. So I have to use these 2 points and find the gradient. Now what is a? A was the gradient of that graph. So how do we find the gradient? Gradient is a change in the quantity on the y-axis, which in this case is e to the y, divided by the change of the quantity on the x-axis, which in this case have change of e to the y values divided by change of the x values. So I substitute. So change of the y values, I have y2, which is 7.6, take away y1, which is 4.4, divided by change in the x values, x2 4.5 minus x1 1.5. Doing the math and solving on my calculator, I have a as 1.06. So this is the value of a. And if you are writing it to 1 decimal place, you are going to have a as 1.1. Now, how do we obtain b? We saw that b is the intercept with the y-axis, or is a point where the line cuts the y-axis. And you see the line cut the y-axis very nicely at the point where e to the y is 3, which is 3. So this is the equation of the line of best fit. The value of a is 1.06 and the value of b is 3. So now we have come to the end of this. Presentation. Congratulations for reaching to the end, and thanks for your patience. Now the next question, which will be in the next presentation, will be on complex numbers and inequalities. So stay tuned to the channel. You can often come once in a while to check if I've uploaded the video. If I have time these days, I'll work on them and I will do another presentation. Now, but before we go, if you have any questions about what I have explained, then please drop them down in the comment section below. If you have any worry on how I have answered some questions, then don't also fail to drop them in the comment section below. And if you have any recommendations for future videos, if you have some challenges in some topics that you would like me to cover, then you can also type them down there in the comment section. And finally, if there are some adjustments, some criticisms, some corrections about the proposed solutions, then don't fail to also write them below, because it helps me a lot, so that subsequently when I want to help my students with these proposed solutions and presentations, I will be able to augment, and then I will avoid making some mistakes as well. Then place your comment down there, and thank you so much for watching to the end, and you all have a wonderful day.